I would like to introduce Resolver, the Excel add-in for production data reconciliation based upon the existing Solver add-in. In the same way as Solver, Resolver uses Excel cell formulas to express the production data reconciliation problem. Therefore, it's ideal for integration within existing spreadsheets which are setting up production reports or reconciliation problems for refineries, petrochemicals, mining, etc. So I'd like to go through a quick introduction to see how easy it is to set up and how easy it is to use. First of all, if you installed Resolver from the download, you will find a resolver.xlsm file which contains this example for you to try. I've laid this example out with the model constraints in the top left hand corner, the variables here in the right, and a diagram to remind me of the circuit. Now, it doesn't really matter how you set it up, but let's go through the constraints. My constraint formulae, as I say, are expressed here in the cell. So here I can see the value of the feed flow into node T5 is the recycle. I like to use variable names rather than cell identities because they can be somewhat confusing, but it doesn't really matter. Resolver will accept both. And then the balance, as in Solver, is expressed on the right hand side. Here I'm saying that equals the lean oil and the separator overhead. Again, I've used variable names, and I could have used cells as well. So these are the constraints that I must balance for my reconciliation. My variables here I've organized in this tabular format. Again, it's not essential, as we see when we run Resolver. But the key is expressing the range. Let me take this example. If I click on that cell, you can see here it is a cell formula. And this is a way of enabling Resolver to be compatible with Solver. Data reconciliation is a little bit different than normal solving problems in that you need not only the adjusted variable, but you need to know the initial estimate and the tolerance of that variable. And the way Resolver does that is it creates this cell array. I enter the cell range here, J7 to L7, and I enter Control-Shift-Enter to make that an array. I've labelled that cell recycle, and I repeated it for the rest. We only have to set this up once for each problem. So I've got my problem set up, so now let's just press resolve. So if I press resolve, bring it into the middle of the screen where you can see, I can see that the constraints and the variables are already set up in a very similar way to Solver. But just to clarify that, let me delete the variables, let me delete the constraints, and let me add a new constraint. So these are the left hand side, and I'm going to select an entire range of them rather than defining them individually. It just saves time. And on the right hand side I have a equally dimensioned array of the right hand side parameters. Let me add that. The next thing I've got to do is tell Resolver all of the adjustable variables. Well, it can work them out. So what we'll do is just press guess, and it comes up, not surprisingly, with the correct variables that we need to adjust. Before I hit resolve, let's just have a look at the options button, and if we look at the options here on the screen, I've got a maximum time allowed of 10 seconds, more than enough. Iterations, that only arises if I have a nonlinear problem. The precision is how close I'm going to get each constraint, and the convergence is how close we're going to get to the least squares or Gaussian cost function. I'll come back to the assume non-negative later, but I'm going to uncheck that for now. So let's go OK. So I've set up the problem parameters. Let me run resolve, and as you see, very quickly get the answer. And even some very large problems with hundreds of variables, hundreds of constraints, linear and non-linear, will give you an answer very quickly. So I'm going to keep the resolver solution. In other words, replace the values on this model with the resolved solution, but I'm also going to produce the answer report. So let's run that, and you can see now, let me close this screen, we can see now we've inserted the solution values in here, so all of my constraint formula are now adjusted to form the balance as we would have expected. As I can see also, I've got a problem there with a negative flow. As I go over each cell, Resolver has conveniently put a comment in there explaining that this variable is observable with the test value of reconciled covariance with 0. Here it's redundant. Here the Salcas is determined. That means that it can determine the value from the measurements that we have, but there's no redundancy. Let's have a look at the reconciliation report here. Let's reduce the size so we can see what's happening on the display. The report is in several sections. The top we have the constraints. I see I've got 6 linear constraints with 12 variables. It tells me the convergence time and the iterations, precision and convergence if it was a nonlinear problem. Here is my global critical value, the redundancy degree, the measurement critical values on the display, which help me determine whether I've got any significant gross measurement errors. As I go down the adjusted variables area, we notice that some of the reconciled tests are highlighted in red. This is where we failed the well-established measurement tests for reconciliation. In other words, this variable is suspect, and indeed we've adjusted it a significant distance from the measured value of 1400 to a reconciled value of 1504. If I go into the constraint area, we repeat each of the constraints, and we also present the reconciled test. This is another well-established test criteria which tells me whether there's a problem with a nodal balance. Here I've got a couple of nodes that seem to have a balance as indicated by the highlighting in red. Well, we also got those measurements. Is it a missing stream or is it a measurement? To help determine that, in the formulae section here you can see we've highlighted the same variables that are in error. Now, so in other words, it looks pretty likely if the recycle's in error, but there was a problem. This fuel gas has gone negative. I don't like that. You don't get negative fuel gas as much as people would wish for that to happen in real life. So let's go back and run the reconciliation again. I'm going to go to the options, and on the options I'm going to assume non-negative. Now if I assume non-negative, what's going to happen now is that Resolver is going to add the constraints to say that no variable can go negative. Let's now run that reconciliation. The reconciliation comes back pretty fast. Go OK. I'll close this, and this time we see the fuel gas has been forced to 0, as we would expect because of the non-negative. If I go to the reconciliation report, a couple of differences that I want to highlight. We can see we've got 18 constraints and 1 active linear constraint. What's happened is that I scroll down the form, Resolver has added these additional constraints here, and one of them was found to be negative, so it's activated it to force that to 0. So that's Resolver in a nutshell. A great add-in to Excel which enables production rate data reconciliation. And I've shown a linear problem handles large nonlinear problems as well. Thank you.